Do you remember problems involving solving unknown values? It is where you use the letter n to represent the missing number. Take this, for example. Grab your pens, paper, and the ruler, and let us exercise our minds in solving simple equations using bar models here on LearnHub. In the equation n plus 2 equals 7, the letter n acts like a blank. This means we want to look for a number that when we add to 2, the answer that we will get is 7. Some of you may already have the answer. What is it? Very good. The value of n is 5. In this lesson, we will learn how to solve these types of equations graphically using bar models. These bar models will help you visualize and manipulate quantities to be added, subtracted, multiplied, and divided. We will cover many examples so you can use bar models in your exercises in the future. Are you ready? Let us have an easy one. Let n plus 4 equals 12. First, draw two rectangles with the same length and width, one on top and one at the bottom. The bar on top represents the left side of the equation, n plus 4, while the bar at the bottom represents the right side of the equation, 12. Let us focus on the top part of the bar, n plus 4. Since it has two terms, we cut it into two parts. Note that the exact length of the bar will not be necessary to solve this equation. So, we can cut it like this. A portion for n and a portion for 4. Now, let us go to the bar at the bottom. Notice that when we cut a portion with the same length with the other bar that is equivalent to 4, we can show it like this. Since the entire bar represents 12, and we just cut a portion equivalent to 4, the other segment must be equal to what number? Correct! It will be equivalent to 8 to complete the bar. What do you notice? The bars that represent n and 8 have the same length. This means that n equals 8. Let us have another example. Try this. N plus 14 equals 39. First step is to draw two bars. The one on top represents n plus 14. The bottom represents 39. What shall we do next? Cut a portion on top equivalent to 14 and another to represent n. Next, let us cut the second bar such that one portion have the same length as the one representing 14. Now, what value must be on the other rectangle such that the total will represent 39? Correct! We will have 25. Also note that the value of n varies, which means that the length of the bar that represents n may also vary. As long as you have bars or rectangles with equal length, these diagrams will mean they have equal values. Our first two examples are about addition. Now let us try another with subtraction. Let n minus 5 equals 4. For this problem, the representation will be quite different. The process of subtraction involves taking away or removing a part of a set. In the subtraction sentence, n is our minuend and 5 is our subtrahend, meaning we will take 5 away from n. But we do not know what the value of n is. In this case, let us first draw a bar for the minuend, the value that we will take away from. This green bar will represent n, again our minuend. Then below this, we will draw another bar. but it is not the same length as n. This second bar in red will be our subtrahend, 5. Finally, one last bar to reach the same length of the minuend. This blue bar will represent the difference, 4, or the answer to this subtraction sentence. What do you notice? The total length of the red and blue bars is equal to the length of the green bar. This means that n must be equivalent to the total of the represented numbers 5 and 4. Hence, the value of n is equal to 9. Now, what if n is our subtrahend? Let us have 25 minus n is equal to 8. First step in subtraction is to draw a bar for the minuend, which is 25. Let us color it green. The second step is to draw a bar for the subtrahend. Since we do not know the value, we will write n. Let us color it red. The third step is to draw another bar for the difference, such that it will reach the end of the first bar. This will represent 8, and let us color it blue. From our addition examples, we learned that the bars with the same lengths are equivalent, meaning, what must be the value of n so that the total of the red and blue bars be equal to 25? Correct! The answer is 17. These mathematical sentences are simple equations. They are mathematical statements that use the 4 fundamental operations in order to solve the single unknown quantity. Let us have an example that uses multiplication and division. Solve for n where 3n equals 18. This expression, 3n, is a simplified version of 3 times n. Now, let us draw two identical bars. The one on top represents 3n, and the one at the bottom is 18. Since we have 3n, we can divide the bar by 3 and name each portion n. This also means 3n. Remember what we talked about bars with equal lengths? Suppose we also divide the bar at the bottom into 3 parts so that we can have similar lengths. So, if we divide 18 into 3 equal portions, how many should be in each portion? Correct. Each smaller bar must be 6. This means that the value of n is 6. Now, let us combine some operations. Solve for n in this equation. 2n plus 11 equals 35. The operation involved is addition, so there must be 2 bars with equal lengths. Let us focus on the left side of the equation and the bar on top. How will we cut this bar to represent 2n plus 11? How many portions will it have? Let us first cut it into 2 parts, since there are 2 addends, 2n and 11. Now we can divide 2n into 2 smaller rectangles with the same length, each representing n. Again, the top represents 2n plus 11, and the bar at the bottom represents 35. Do you remember what you'll do in this situation? Let us cut a portion at the bottom equivalent to 11. What will the other portion of the bar be equal to if the total is 35? Correct! It will be 24, since 35 minus 11 is 24. Now, this portion is equivalent to 2n. So we will divide this into 2 equal parts to get a portion similar to n. What will be the value in this segment? Correct! 12. Thus, in the equation 2n plus 11 equals 35, the value of n is 12. Let us now try to answer this. Find the value of n in 3n minus 8 equals 7. Take note that you have your minuend 3n, your subtrahend 8, and the difference is 7. Let us draw a bar for the minuend 3n. Then below it, proceed to draw a bar to represent the subtrahend 8 and the difference 7. Note that the length of 3n must be equivalent to the length of the two bars at the bottom. This means that 3n is equivalent to 15. What do you think is the value of n? Dividing 3n into 3 equal portions, we can say that we shall divide 15 by 3, which will result to 5. N equals 5. One last example where n is in the subtrahend. Find the value of n in the equation 24 minus 2n equals 6. What is your minuend? Correct, it is 24. Let us draw a bar for 24. What is the subtrahend? It is 2n. Since we do not know n, let us draw a rectangle with a known length for 2n. Then, another for 6, the difference. What do you think is the next step? We can cut the bar representing 24 into two parts, where they have the same lengths as 2n and 6. If the right side of the bar is 6, what do you think will be the value to the left? Correct, it will be 18, since 24 minus 6 is 18. Now, remember that this red bar, 2n, has the same length as the bar that we derived, 18. Dividing both bars into two equal portions, what will be the value for n? Correct, n must be equal to 9. Now, try this on your own and see how much you have learned. You will be given 20 seconds to work on this problem. Are you ready? What is the value of n in the equation 4n plus 1 equals 33? If you answered 8, then you are correct. Check this model. Do you have a similar one? Now let us have one last test. Find the value of n in the equation 3n minus 5 equals 13. If you answered n equals 6, then you are correct. Check your model if it is similar to this. There are different ways to solve simple equations. The important thing is to practice mastering the process of using bar models. That is one of the more concrete and visually appealing methods to learn this skill. I hope that our examples in this lesson help you in understanding the steps or techniques to find the missing or unknown value. That's all for today, and keep on being critical, logical, and responsible little mathematicians. Tune in again to Learn Hub and learn the way.